Quiz 5.4 Review Calculus with Mr. Walton. Key concepts. Number one, we want to remember that differentiation and integration are inverses. So please also recall that the fundamental theorem of calculus says that the derivative of the integral is the original function. For example, find dy dx given the integral from 1 to x squared of sine of t dt. Don't forget our hint that the derivative of the integral will give us the composition of the functions times the derivative of our f of x. So, therefore, we're looking at y equal to the integral of sine of t dt, which means we can now say that dy dx is equal to the integral from 1 to x squared of sine of t dt, which then means we can say it's the derivative of this integral, and therefore we calculate dy dx to be the sine of x squared times dx, and dx is 2x. Therefore, we get final answer, dy dx is equal to 2x sine of x squared. Key concept number 2. How do we tell the difference between total area and net area? Please remember that the total area is geometry. Think geometric. Therefore, we're taking the absolute value of the integral. Also, the net area is straight up regular, quote unquote, regular integration using a definite integral. So, let's look at some tips for finding the total area. First, find the zeros of the interval. Second, use the sign chart to determine positive and negative subintervals. These are the intervals within the whole interval. Third, integrate the subintervals separately. And fourth, calculate the sum of the absolute values of the areas. Let's look at an example. Find the total area of the region between the curve and the x-axis, given f of x is equal to x squared minus 4 on the interval from 0 to 4 inclusive. Number one, we're going to find our zeros. So we're going to set x squared minus 4 equal to 0. We get x squared is equal to 4. X is equal to plus or minus 2. Please realize that we only have x is equal to 2 as x equals negative 2 is not on our interval. Second, we're going to look at whether it's positive or negative. So I'm going to create a little number line here. We have 0, 2, and 4. Pick a value between 0 and 2, plug it in. If I put 1 in there, I get a negative value. Pick a number between 2 and 4. Let's pick 3. 3 squared is 9. 9 minus 4 is 5, and that's a positive value. So now I know I'm going to break this up as an integral from 0 to 2 and 2 to 4. And this is step 3. Alrighty. So then we're going to put in our function x squared minus 4 dx. We're going to solve to get x cubed over 3 minus 4x from 0 to 2 plus x cubed over 3 minus 4x from 2 to 4. When we solve this, we get negative 16 thirds, 32 thirds. We're still adding them together, but what do we need to do to make sure we have the total area? We need to ensure that we are taking the absolute value for a total area that is equal to 16. Key concept number 3. Remember the derivative of our capital F function versus f of x. Now, when we talk about the big function capital F versus our regular function f of x, here are some things to remember. Therefore, let's look at an example. Suppose the integral from 3 to x of f of t of dt is equal to tangent of x plus 3x. Find f of x. Therefore, we need to be reminded which one of these helps us. This is the last piece that we just saw right here. We can say that f of x is equal to the derivative of the integral 3 to x ft dt. Now we want to substitute this piece, the integral, is actually equivalent to and we want to take the derivative of this quantity to find our f of x value. So if we take the derivative, we will find that secant squared x plus 3 is our f of x. Make sure you study all these concepts and your notes to prepare for the quiz.